Hello guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is perfect number. So in this question, we have given x, y and bound. So the main constraint is that main condition that is x raised to I plus y raised to j is less than equals to bound. Okay. So this is the main condition and we need to satisfy this condition, and if we are changing the values of I and j, that means x raised to power I and plus y raised to power of j, it value should be less than equals to bound, and there are some answers like this. So we can get these answers. How? Firstly, firstly we are talking about constraints. So for I and j, we have given this value should be less than equals to 0 and less than equals to 10 raised to 6. After that, bound. Okay, bound's value is less than equals to 1 or less than equals to 10 raised to 6. Okay, after that, x and y. This value is less than equals to 1 and less than equals to 100. Okay, this is the constraint that we have given. And by changing the value of I and j, we are going to make some combinations of this, and that combination, by using that I and j's combination, we are taking the sum of these two numbers and it will be less than equals to our bound. So our x is 2 and y is 3. So let's make some I or j's combination that makes this answer value of this. Okay, so I, let's take I 0 and j is also 0. So 2 raised to 0, 1 plus 3 raised to 0, 1. So 1 plus 1. Now 2 raised to 1 plus 3 raised to 0. Now 2 raised to 1 is 2 plus 1, 3. 2 raised to 0 plus 3 raised to 1. 1 plus 3, 4. 2 raised to 1 plus 3 raised to 1. 2 plus 3, 5. 2 raised to 2 plus 3 raised to 0. So it is 4 plus 1, 5. So the values are same. At this point, values are same. So for our answer does not contain same values. So for avoiding this, we are going to use set. Why not map? Map contains key versus value. We don't want that frequency map okay. We don't want that frequency map. For that, we are going to use here set. Set contains only distinct values. Okay, only distinct values. Now 2 raised to next pair that we can make, the next combination that we can make, that is 2 raised to 2 plus 3 raised to 1. 3 plus 4, that is 7. 2 raised to 3 plus 3 raised to 0. 8 plus 1, 9. After that, 2 raised to 0 plus 3 raised to 2. 9 plus 1, 10. So all the combination that is present in the answer that we are made here, but we are especially make sure that it is not double repeated in our answer. Okay, it is not repeated in our answer. So we are going to use set here. So solving this question, for solving this question, okay, let's take this to another slide. Okay, these are some combinations and we need to make sure that this is not repeated in our answer. Now for solving this question, our x and y constraint is 1 plus 1 to 100. So our x raised to i's value is always been a positive value, and y raised to j's value is also been a positive value. So our x raised to I is less than our bound, and also same for y raised to j is also less than bound. Why it is not equals to? Why x raised to I is not why x raised to I is not equals to that means why x raised to I is less than equals to bound? Why we are not taking equals function equals value here? Why why we are not using equals operator here? Because if let's say bound is 100 and this value is also 100, then 100 is less than 100. it is not possible, it is not a true value. Okay, so we are saying that both, if both are comes, then we are saying that it is less than equals to bound. We need to satisfy this condition. Okay, so if this x raised to i's value is 99 plus y raised to 0, that is 1, then we are saying that it is less than equals to 100. So 100 is less than equals to 100, and this condition is satisfied. This condition is satisfied here. So for that, we are not taking that, we are saying that this is not possible. Sorry, this is possible, this is not possible. Because if we are taking any number raised to 0, then it will give 1 as the answer. Now let's solve this question. Our firstly, our x raised to I should be less than bound, and y raised to j is also should be less than bound. Okay, now for solving this equation, we are going to use a log here. Log. So log of x to the base x, log of x raised to power I to the base x should be less than log of bound bound to the base x, and for same for the y also. So let's write here log of y raised to power j of base y is less than log of bound to the power y. So for solving this, I is at this point. Now log x to the base x, it is going to be 1, is less than log x to the log x to the base of b. Okay, now at this point, j is at this point, and log y it is going to be 1 and less than log y to the bound. Okay, so I is less than log of x of bound, and j is less than log of y bound. Okay, now we need to solve this equation. Okay, if we are solving this equation, our problem will be sorted. Now let's say that log to the base a of b. We don't know, so we don't know how to solve for log to the base a, but we know how to solve log to the base 10. So we are going to use here, that is let's say this. Okay, log to the base 10 of b divided by log to the base 10 of a. So applying this condition over this expression, so I is less than log to the base 10 of bound divided by log to the base 10 of x. So our x is what we are taking, what is the value that we are taking for the x in this equation. So for solving this equation, we are going to use the maximum value onto the numerator and the minimum value onto the denominator. So it can give us the maximum number of possible combination that we can make by using the I and by using the j. So the bounds constant is, it is less than equals to 1, and it is goes up to 10 raised to 6. So maximum that we can take here, let's change the pen color, log to the base 10 of 10 raised to 6. Okay, and at the divide part, log to the base 10 of x. So we have to take the minimum number here, minimum number that x can be produced, x can be start with, that is 1. But if we take a power of x, if we take a power of that means 1 raised to any number, then it will give us 1 as a value. So it will not give us some another different number of combination. For avoiding that, we are going to use 2 as a minimum value. So log to the base 10 of 2. So now we are solving this equation. So the log of 2 to the base 10's value is somewhere like 0.2327. So we are taking the approx value here. I is less than here 6 is at this side, log to the base 10 of 10 divided by 0.3. This is the approx value, not a final value, approx. Okay. Now I is less than let's solve this. This is a 60 divided by 3 and going to the 20. So at this point I is less than 20. Similarly, if we solve for j, it is also comes j is less than 20. So it is a very small number, very small number of combination that we can achieve by using this range. Okay, so our I and j's range is in between 0 to 20. So the number of combination that we can make by using this range, that is 20 into 20, that means 400. So maximum number of combination that we can produce by using this range, that is 400. So here let's say a raised to 0, a raised to 1, a raised to 2, and a raised to 3, and a raised to 20. Okay. Similarly for b raised to 0, b raised to 1, b raised to 2, and b raised to 3. Similarly b raised to 4, b raised to for 20. Okay. So this a raised to 0 can make combination with all these. This 1 make combination with all this. This 2 make a combination with all this. 3 can also make a combination with all this. So for achieving this combination, we are not going to use the power function. We are going to use a for loop here. Let's see some pseudocode type for loop. So for loop, I is starting from 1 and I is less than bound. Okay, I is less than bound. After that, I is multiply equals to a, and let's try to print I. So this is the end of for loop. So let's try. I is at 1, printing I, that means 1. So 1 we can write 1 as a raised to 0. So any number raised to 0 is 1. So updating our I, it is firstly 1, updating our I as a. So a into a, that means a raised to 1. Updating our I, multiplying a into a, that is a square. So it is a square. Again multiplying a with a square with a, that is a cube. Printing that, updating that a cube into a, that is a raised to 4. Again printing that a raised to 4. So we can get this type of this type of combination by using this for loop. So for solving this question, we are going to use set for not let's see here, for not repetition of same value in our answer. Okay. Now this is my approach. So from this we are going to code this question. So let's start with the code. We are going to code in Java. Let's do a full screen first and start with this. So we are going to use a hash set here, hash set here, hash set of integer. So we can say that it is a set of hash set. Okay, like this. Now we are going to make a combination for I here. So I is starting from 1 and I is less than bound, and I into equals to x. Okay, and the second loop for making the combination for j. So it is also starting with 1, but we are writing this condition here. It should be less than equals to bound, and j, we are updating our j as a multiply into multiply equals to j. So we are updating our j is like this. Okay, so set dot add I plus j. Okay, we are updating the combination into our state. Now at this point we need to make sure that what uh, our x and y is greater than equals to 1 and less than equals to 100. So y can be goes up to 1 and x can be goes up to 1 also. So if our y's value is 1, if our y's value is 1, so we are updating our 1 into 1, 1 into 1 into 1 into 1, and this loop will be goes into infinite loop. Okay, we need to terminate this loop. If we can't terminate this loop, so this this answer says that array out of bound. Okay, yeah, or stack overflow. So if our y is equals to 1, then we need to break from this point, and for x is also, or if our x is equals to 1, then again we need to break from this point. If our x is also going to be 1, then for the updating purpose, we are updating the x as 1 into 1 into 1 into 1, and it is goes into infinite loop, and we need to we can't terminate that loop, but we are going to check here, that is x is equals to 1. Now after doing all this, let me clean this. After doing all this, we need to return the state into array of integer. So new array list of state. Okay, we can return this state into this type. Let's try to run this code. So it is run for the sample test case. Now let's make again. Okay, so the first loop is making combination for I. The second loop is making combination for j. Okay, and this loop will run into log of I and log of j. Okay, so our time complexity is log of I into log of j. Okay, and the space that we can take here, that is also in log of I into log of j. That number of combinations that we can achieve, that is also the space complexity is also same. So at this loop is making combination for I, and this is for j. At this point, we are adding that combination into our set, and this condition checks that is our I plus j's combination is less than equals to bound. If it is true, then we are coming into this loop and adding that into set. After that, we are checking is our y's value 1. If this value is 1, then our loop will be going into infinite loop, and it will be not terminated. So for that, we are checking this condition for y and for the x. So this is the full code. So I hope you understand the question and the solution of this question. Thank you for watching.